From our earliest days, humanity has gazed at the stars and wondered about our place in the cosmos. Among those celestial wonders, Mars, the red planet, has held a particular allure. Its reddish hue, visible even to the naked eye, sparked tales of war and conquest in ancient cultures. Today, our fascination with Mars has evolved into a burning desire to explore and understand this alien world. For centuries, Mars remained a distant object of our imagination, a symbol of the unknown. But with the dawn of the space age, our dream of reaching out and touching the red planet transformed into a tangible goal. The journey began with robotic emissaries orbiters that mapped the Martian surface, and landers that probed its secrets. Each mission brought us closer to unraveling the mysteries of our celestial neighbor. Now we stand on the cusp of a new era, one where humans will no longer be confined to Earth. Mars, once a distant dream, is now within our grasp. The technologies and knowledge needed to send humans to Mars already exist. What remains is the will to make it happen. The colonization of Mars represents the next giant leap for humanity. It is a challenge that will test our limits, push our ingenuity, and ultimately redefine our place in the universe. As we embark on this extraordinary endeavor, we carry with us the hopes and dreams of generations past, and the aspirations of countless generations to come. The red planet beckons, and we must answer its call. Reaching Mars presents a significant technological challenge, but it is one we are well equipped to overcome. The journey to Mars will be a multi-stage process, requiring careful planning and execution. The first stage involves developing powerful and reliable launch vehicles capable of carrying the necessary crew, equipment, and supplies into Earth orbit. These rockets will need to be significantly more powerful than those currently in use, capable of lifting massive payloads out of Earth's gravitational well. Once in Earth orbit, the spacecraft will undergo assembly and final preparations for the long journey to Mars. This interplanetary craft will consist of several modules, including living quarters for the crew, a laboratory for scientific experiments, and a landing module for the descent to the Martian surface. The journey to Mars will take approximately 6 to 8 months, during which the crew will be exposed to the hazards of deep space, including radiation and microgravity. To mitigate these risks, the spacecraft will need to be equipped with advanced shielding and life support systems to ensure the crew's safety and well-being. Upon reaching Mars, the spacecraft will enter orbit around the planet, allowing the crew to survey potential landing sites and conduct further scientific observations. Once a suitable location is chosen, the landing module will detach from the main spacecraft and begin its descent to the Martian surface. The first human presence on Mars will be a modest but crucial step in establishing a permanent human presence. This initial outpost will serve as a base of operations for scientific research, exploration, and the development of essential infrastructure. The initial outpost will likely consist of prefabricated modules designed for easy assembly and expansion. These modules will house essential life support systems, living quarters for the crew, a laboratory, and a communications center. One of the first priorities will be to establish a reliable power source. Solar panels will likely be the primary source of energy, supplemented by backup generators. The outpost will need to be designed for self-sufficiency as much as possible. This includes developing systems for recycling water and waste, as well as growing food in hydroponic gardens. The initial crew will consist of scientists, engineers, and medical personnel, with the skills and expertise needed to establish and maintain the outpost. They will conduct vital research on the Martian environment, search for signs of past or present life, and lay the groundwork for future expansion. As the initial outpost expands and more crews arrive, the focus will shift towards establishing a permanent human settlement. This will involve developing infrastructure and technologies to support a growing population and create a sustainable way of life on Mars. One of the most critical aspects of building a Martian settlement will be developing robust life support systems. This includes creating closed-loop systems for recycling water and air, as well as developing advanced waste management techniques. Agriculture will play a vital role in sustaining a Martian settlement. Hydroponic farms will allow for the cultivation of crops in a controlled environment, while research into Martian soil and climate may eventually enable outdoor farming. Expanding the settlement will require the development of construction techniques and materials suitable for the Martian environment. This may involve utilizing local resources such as Martian regolith, soil, and ice to create building materials. As the settlement grows, so too will the need for social infrastructure. This includes establishing systems for governance, education, healthcare, and recreation to ensure the well-being and prosperity of the Martian population. A breath of fresh air. Creating a Martian atmosphere. Transforming Mars into a more Earth-like planet will require terraforming, a long-term process of engineering the planet's atmosphere, temperature, and environment. Creating a breathable atmosphere is a key challenge in making Mars habitable for humans. Mars currently has a very thin atmosphere, about 100 times thinner than Earth's, composed primarily of carbon dioxide. To make the Martian atmosphere breathable for humans, we need to increase its density and change its composition. One proposed method for thickening the Martian atmosphere is to release greenhouse gases trapped in the planet's polar ice caps and permafrost. These greenhouse gases, such as carbon dioxide and methane, could trap more heat from the sun, warming the planet and thickening the atmosphere. Another approach is to direct comets or asteroids rich in volatiles, such as water and ammonia, to impact Mars. The impact would release these volatiles into the atmosphere, contributing to its thickening and potentially delivering water to the planet's surface. These terraforming efforts would take centuries to complete, but they could eventually transform Mars into a more hospitable world with a thicker atmosphere, warmer temperatures, and liquid water on its surface. Oxygen for life-sustaining a breathable environment. While thickening the Martian atmosphere is crucial, we also need to convert the predominantly carbon dioxide atmosphere into one rich in breathable oxygen. This will require innovative technologies and processes to extract oxygen from Martian resources. One promising method is electrolysis, which uses electricity to split water molecules into their constituent elements, hydrogen and oxygen. Mars has significant water ice deposits, particularly in its polar ice caps and subsurface permafrost. This water ice can be extracted and used as a feedstock for electrolysis, generating breathable oxygen. Another approach is to utilize photosynthetic organisms such as algae or bacteria to convert carbon dioxide into oxygen. These organisms would need to be genetically engineered to thrive in the Martian environment, but they could offer a sustainable and efficient way to produce oxygen on Mars. As oxygen levels increase, they will contribute to a denser atmosphere, further enhancing the greenhouse effect and warming the planet. This positive feedback loop could accelerate the terraforming process, eventually leading to a more Earth-like environment on Mars. Living on Mars: challenges and opportunities. Life on Mars will be unlike anything we have experienced on Earth. While technological advancements will address many challenges, living on Mars will present unique opportunities and require adaptations to a new way of life. The lower gravity on Mars, about 38% of Earth's, will have long-term effects on human physiology. Muscle and bone density loss will be a concern, requiring regular exercise and potentially medical interventions. The Martian environment is harsh and unforgiving. Extreme temperature swings, high radiation levels, and the thin atmosphere pose constant challenges. Habitats will need to be designed for safety and self-sufficiency, providing protection from the elements and a reliable supply of resources. Despite these challenges, life on Mars also offers incredible opportunities. The Martian landscape, while desolate, is also breathtakingly beautiful. Exploring vast canyons, towering volcanoes, and ancient riverbeds will be an awe-inspiring experience. The opportunity to conduct groundbreaking scientific research on Mars is another significant draw. Studying the planet's geology, climate, and potential for life could unlock secrets about the formation of our solar system and the origins of life itself. The Martian future: a new home for humanity. The colonization of Mars represents more than just a scientific endeavor. It is an investment in the future of humanity. By establishing a permanent presence on another planet, we ensure the survival of our species beyond Earth. As technology advances and the Martian settlement grows, new industries and economic opportunities will emerge. Mining Martian resources such as water ice and rare earth elements could fuel economic growth and support further expansion. The challenges of living on Mars will foster innovation and creativity, leading to technological advancements with applications both on Earth and in space. The knowledge gained from terraforming Mars could also provide insights into combating climate change on our own planet. The colonization of Mars will also have a profound impact on our culture and society. It will foster a spirit of international cooperation, unite humanity behind a common goal, and inspire future generations to push the boundaries of human exploration. The establishment of a Martian civilization will mark a new chapter in human history. We will have transitioned from a single-planet species to a multi-planetary one, forever altering our destiny and securing our place among the stars. A giant leap for mankind. The colonization of Mars is an ambitious undertaking, but it is an achievable goal. The technologies needed for this grand endeavor are within our grasp, and the potential rewards are too great to ignore. The journey to Mars will be long and arduous, fraught with challenges and risks, but the human spirit of exploration, innovation, and determination will see us through. We have landed on the moon, and now we set our sights on Mars, driven by the same unyielding curiosity and thirst for knowledge that has always propelled us forward. The colonization of Mars will be a defining moment in human history, a testament to our ingenuity and our unwavering belief in a brighter future. As we embark on this extraordinary adventure, we carry with us the hopes and dreams of all humanity. The red planet awaits, and we are ready to answer its call.